Okay, great. So through my next 20-25 minutes, I'll be spending mainly on these points. Some of the time I'll be spending on PowerPoint presentation and some through live demonstration on NXCAM. See, we all know what NX is and how it is populated inside the people and the strength it possesses. For any industry, whether it is automotive, aerospace, oil and gas, NX has its footprints all over. For this webinar, because our topic is transforming our manufacturing way through more digitally, let's see few of the things which NX can offer. NX has about 50 years presence in CAM business. It has been a priority for the users, right from single shop owners, expanded up to the OEMs. We have around 70,000 plus seats installed worldwide. And you see any survey from SIMData, from automotives, we occupy #1 position in CAM industry. NX CAM predominantly covers 3 segments: mold and die, production machining, complex parts. For mold and die, we don't have choice. We have to have any CAM software, and NX has the edge. Whether it is the super finishing of the job, whether you have the very hard to cut materials, whether you have any kind of dies, whether it belongs to automotive sheet metals, skin parts, the electronic parts, any kind of die and mold industry, whether it is instrument and mold, instrument panel mold, or the car hood mold, the stamping die for the roof, anything. The demand is of the very high finish, and NX achieves it very beautifully. Second category, production machining. In production machining, it's not mandatory to go for a CAM solution. You have the choice to work manually or through CAM. But if you see the benefits what CAM offers for production machining, take my words, once started using CAM, once the CAM is tested, you don't look back for manual programming because the benefits are immense. And for the third category, complex parts, yes, NX has everything you look for. You have so much of choices for creating the strategies, for controlling the projection vectors, for controlling the patterns, for controlling the tool axis. There won't be anything if you think you want to machine it that way, and NX does not give you the latitude, the freedom to do that. This is a brief snapshot of what NX CAM covers. Whether it is high-speed machining, 2.5 axis, 3 axis, 5 axis, or automated special category of machining, melt turn, wire radium bonding, NX covers everything. The portfolio of NX is the most wide. Whether it is CMM, whether it is robotic machining, whether it is on-machine probing, everything is encompassed by NX CAM. You have the job, NX has the solution. Need not worry about the complexity of the job. We have the solution for everything. You won't find your hands bound by anything to machine any part. NX CAM gives the flexibility to the designer, the freedom to design whatever way he thinks of. He does not have to have any constraints in the mind whether it will be machined or not. Think as wild as you can, the designer, and the CAM engineer will do it. If design is the brain of the company, manufacturing is the muscles of the company, and NX CAM gives that protein, that vitamin, whatever minerals to those muscles for the company. we have various strategies to machine the things. If because we have a seminar for 20-25 minutes left, I cannot show you all the capabilities. But if you go for any kind of strategy you look for, NX has, and that too with full freedom, whether it is adaptive, trochoidal, whether it is high-speed machining, high productive machining, NX has a solution for everything. If the participants in this webinar are from actual user side, they might relate this programming to their usage. The latest edition of NX machining by guiding curve, you see the finishing which is achieved by this method vis-a-vis other conventional methods. You'll see the real benefits what NX can offer. And in NX, people say you are changing things quite often because there are so many brains working behind NX which come out with new strategies, new advancement every 3 months, every 6 months. There are lot many improvements which come on regular basis. That's why NX maintenance packs, NX new versions come very fast. NX has everything plus customizable. We have the tool libraries which come inbuilt into NX and that too customizable. You select your machining data, cut method, tool material, part material. Based on the permutation combination, NX has already built a tool library. But if you want yourself to be built a library, you can definitely do that. There's nothing which like Op Center, there's Accelerator. There are so many things on which you can build your own things and customize NX. We have latest editions of deburring. You can do planar deburring, you can do 3+2 deburring, you can do 3-axis deburring, you can do multi-axis deburring. You need not select anything. NX by default selects all the edges which require to be deburred. You just model the part with chamfer, without chamfer, anything, and NX will deburr it. And it's just selecting the part and creating the operation. Nothing more than that. These advancements are coming on every quarter basis, every 6 monthly basis. When you program a complex part, maybe a mold, NX divides that complete part into multiple regions. And you can have the strategy for each and every region separately. You need not create multiple toolpaths for different subcategories, different areas. You can do that. You have the freedom, but still, if you are selecting the complete part, NX will not deploy one strategy to the complete part. It breaks the part into multiple regions, and you can select the region and you can select the strategy for particular region as per your wish. And to do that, NX gives all the options in it inside NX interface. Then in 2.5 milling, you might have seen the other softwares. Sorry. Is there any question, please? Okay. Let me go.
I think there was some disturbance between. It's okay. You can continue, Sandeep.
Okay. So if you compare it with other softwares, right from 2.5 axis milling, NX gives you the freedom to use or create toolpath based on volume for 2.5 axis also. For curve-based machining also, point-based machining also, you can generate IPW from a solid blank. Even if your model is not ready, you can create the toolpaths on curve basis and make in-process workpiece from that curves also. 2.5 axis as mill planar, then you have mill contour, mill rotary, mill multi-axis turn mill, all those categories branched together into groups. You can select your category and do the best use of it. We have the solution for multifunction machines also, wherein you have multiple spindles, multiple channel machines. Like you have turret in front, you have B-axis tool holding system in the rear, you have steady rest. everything can be simulated also. And you can synchronize two turning operations together on a main spindle. If you have two channels, means you can have multi-channel turning operations synchronized together through a synchronization manager. You have every flexibility. You want continuous B-axis turning, you can do that. You want to make a turning operation using a milling cutter, maybe for burnishing or for grinding, you can use that. You want to generate a generic motion for from main spindle to sub spindle part takeoff, you can do that. So every freedom NX gives. Then we have multiple part machining through a tombstone. You can, on a fixture, you can have multiple parts mounted together, make a toolpath for one particular part, and then move, copy, instance, pattern, like the way you pattern your curves, your features, your geometries, same way you can do with the toolpaths also. No restriction for any means you have generated a 3-axis, let's say you have generated a 3-axis toolpath. You can convert that 3-axis toolpath to 5-axis without having mill multi-axis. With only mill contour category of sub operation, you can tilt the toolpath if your machine permits. You have the software for 3-axis, the machine for 5-axis, you can convert 3-axis operation to 5-axis operation using toolpath tilt. If you have mill multi-axis, that has many advantages, but even 3-axis toolpath can also be tilted for 5-axis machines. Like many times you have deep cavity, like this is for a Toyota hood, the sheet metal part. It's so deep, so you need not have the very long tools in vertical machining. You can tilt the toolpath and use a shorter tool. For 5-axis machining, we have multiple options. You can do 5-axis roughing also. You can do Z-level machining using tilted tool. And an NX gives you a push to select the automated strategies. Knowledge has been built into NX interface. You need not spend select multiple things to make of your own. NX will give you the best strategy based on the part geometry. But still you can select from your own also. We have some special modules for impellers, for engine pockets, for ports, in which you have to select the tool and the part. Rest NX does. If you make it, if the same program you try to make it using the standard functionalities, you might take 2 days to program that job. But if you have turbo machinery, you have tube machining, you just have to select the part and NX will do, and you can create that within maybe in half an hour, which requires 2 days using the standard techniques. Then we have something called as programming automation, wherein NX recognizes features based on the part geometry. If it has holes, it has pockets, it has planar faces, NX will recognize on its own. And you need not select your strategies based on the knowledge which is already built in. You can reuse that knowledge and create the toolpath much faster. And the programmer who is doing that and the operator who is going to run that operation will have double confidence, because it's a reuse of knowledge. He knows the earlier operation was also this sort and it had run successfully. This time also he will have much higher confidence. How does it work? Just let me go back. It first recognizes the feature, creates the operation, just generates the toolpath, optimizes, and gives the NC output without much of the involvement of the user. Then for drilling, we have enough strength in NX. For any curve, any hole, means round hole, any point, you can call that as feature and do the drilling in multi-axis. You can pick the feature through a window, no problem. And NX will create the best drilling path. You want the output in cycles, NX will give the output in cycles. You want the output in linear moves, NX can give that. And the post will take care whether if you are using a FANUC controller, G81, G83, everything will be post processed as per the cycle selected. If it is Heidelin control or Siemens control, cycle 8, whatever, means based on the controller, the post will take care of the right output. Then we have something called as PMI. If you create the models and give the dimensions in 3D, then it propagates to NX CAM also. If you have given H7 hole in PMI and you are using knowledge-based machining in NX, then you select that feature, NX will create automated sequence of operation wherein first could be drilling, the second could be reaming or boring if required based on your requirements. So if you give PMI right way, NX will create the right operation using feature only and PMI. It understands why H7 is given. It understands why that surface finish is given. You just click and it selects all the feature, and based on knowledge, it generates the same tool path for pocket, same tool path for drilling, same tool path for faces. By same, I mean the strategy, the sequence, and the features which were used for previous operation. Let's come to post processing in simulation. We have three kinds of simulation. We have internal toolpath verification, we have machine tool simulation, and we have external G-code, M-code simulation also. You can, if you have your machine tool ready, machine kinematics ready, then you can actually simulate the GM coded output file on the machine itself in the same interface. Besides that, you can bring in any of the NC file generated from any source, maybe manually or from any other source. You can simulate that NC file in NX interface too, in the same NX file. Need not be generated through NX. So posted NC file from NX or coming from outside, you can simulate both within NX. Then with NX, when you install NX, there are so many of out-of-box machines available of various kinds, whether it is 3 axis, 5 axis, 4 axis, multi-channel machines, terminal machines, VTLs with a live tool. Most of the machines are available out of the box, which you can use for simulation and then creating those or converting those machines to your kind of machine, because you can use these machines as your setup templates. Then for increasing the productivity, we have so many of NX CAM techniques, which means any software can develop or generate the toolpath for any surface. But why NX? NX has a single strong portfolio covering everything. In the same file, you can have CAD. In the same file, you can have CAM. You can have simulation. You can have drafting in the same NX file. And all are integrated together. You design your product, you design your tooling and fixture, you create the toolpath, you do the CM inspection programming with the same route. If one thing gets changed, everything can be changed. It gives you a notification, parent has been changed, dependency highlights that something has changed, whether you want to update, hold on or something, it gives you freedom for everything. Then it's not milling only. We have EDM solution for turning, EDM, everything. And then Once you have post-processed, simulated, then you can have the shop floor documentation ready from NX only and the shop floor connectivity also. You need not have a separate DNC system. From NX also, you can directly pump the program to the machine. And about CAD functionalities, it has already been shown the various things. I'll not repeat it, but yes, we have the complete package for everything required in any manufacturing industry, whether it is part model preparation, fixturing, CAM, shop floor connectivity, the documentation, the CMM program generation, everything, robotic machining, all things are closely bound together, knitted together. NX, because it has complete portfolio, that's why it has an edge. Okay, let me go back and show some of the programming techniques which I use to make this part. What is the time? Okay, I still have 10 minutes. So this was a part which was designed by Vishnu. He gave this part to me. Now I'll bring the same file. I'll generate the operations required to machine this part. To save time, I have already generated few. The first thing I do is I select the MCS, which is okay. Just a second. I have not shared my screen. Let me share my screen and NX window. Okay. So is my screen visible now? Okay. I'm sorry. So Vishnu gave me this part. Now I'm going to set my MCS, the machine coordinate system. Unlike other softwares, we do not need to move part anywhere. We will set our MCS wherever we require. Okay. So we can keep our MCS anyway. We can have multiple MCS, no problem. We set our MCS main spindle. If it is going to be on a turn mill machine, I'll have the same way MCS. If it is going to be on a 5-axis machine, I can have same way MCS. I'll generate the operations and then before posting or before simulating, I'll bring the machine in. At the moment, I'm just creating rough turn, finish turn. I have created all the operations. Let me show quickly the video which I have already recorded. And if of any interest, I can show you. Okay, I'll have to share again, just a second. Okay. So this is normal internal toolpath verification. You create the operations and this is very common, like you have normal toolpath verification for any job. In NX, whether it is turning, milling, everything can be done in the same cycle setup, same MCS setup, same workpiece. And the in-process workpiece carries over from one operation to another. If you have done turning, the same workpiece you can shift to milling. Same way, it's very common in any NX of any CAM software. We can have this machining fast. Let's finish it vertically first. To let's say 60-70 mm height we do. Okay, then we shift to rotary milling. Now we are doing rotary roughing, which is again a strong point of NX, mill rotary, wherein you just need to give the part to be finished and the blank, and NX create the optimal path for 4-axis roughing. You need not select a particular surface. It will generate the tool path based on part, based on IPW, and will remove the material after leaving the stock which you had given. It's a 4-axis tool path, mill rotary. Then in the same, we can finish the flutes areas. Same 4-axis mill rotary. And once the flutes are finished, then we can shift to the carbide drilling, PDC cutter drilling, normal drilling, and you can pick all the drills together. You just need to create the windows and everything will be picked. Need not pick one by one. Once picked, then you can change the sequence as desired. You have multiple options to control the sequence of the drilling. If you want the shortest path, you can do that. If you want is in one direction, one, and then in next direction, you can do that. And in hole making, you have all the controls, whether you want helical milling, you want spiral milling. Inside hole making, you can do as you wish. Because these are open holes, so better to do hole milling here. So what we are doing is internal toolpath verification. So far, NX does not know on which machine it will be running. So once we are clear that my programming is complete, now I have to run this machine on, let's say, CTX Gamma or DMG machine. I can bring in that machine and then simulate the posted codes, the NC codes created for that machine on a particular machine. If I created the NC codes for CTX Gamma, I can simulate same thing on CTX Gamma. If I post it for DMU, I can do it for DMU. Let me show you on NX Live. Okay. So now this is NX interface. Let me bring my machine now. If I am doing it on CTX Gamma. Let me hide the case. Okay, this is my machine. And let's say, let me simulate just finish path, finish turning path. I'll simulate only a few operations. Okay. If you see here, we have multiple ways in this drop down. Okay. So here we have toolpath based simulation, machine code based simulation, external program simulation. So we can simulate a external program also. Let's simulate machine code based simulation. Simulate that. Okay. And now you see these are the codes which have been written by post processor, and you are now simulating these codes actually, not the toolpath which is generated inside NX. Now these are the codes which are being simulated. Continuous BXS turning, BXS tilts, and moves further. Okay. Yeah, let me simulate some PCD hole mill. It brings it first posts the toolpath and then it simulates that posted toolpath. Okay. Let me reduce the speed bit. So let me hide that. Just a second. Let me hit material remover. Might take some time to bring in the material. And let me hide that. Okay. Let me play now. Let me do some drilling of, let's say, nozzle hole. Machine code simulation. Let me hide the basic part. Okay, and let's see, simulate that. This is for nozzle counter. Right. So in this, you can actually visualize whether your machine is touching somewhere or not. You can, before giving the toolpath, you will have 200% confidence that my toolpath is correct. This was on the CTX machine simulation. The same, once you have put in your effort for program generation, you can run the same toolpath on multiple machines if you have the model with you. Let's say, let me do this nozzle or PCD whole mill on this machine, simulate machine. This is the last, this just 2 minutes more and I'll be over. Okay. And let's say we simulate now. Now these codes are based on DMU machine. Going to home. Tool is clamped. Okay. Now you can have all those holes. You can have your tool trace, how the tool is moving. So that way you can have any simulation. Either it is toolpath based or machine tool based or external created GM code file. So because time is over, so I'm done. I will not take further time. So from my side, I'm done. Pramod, it's on to you now. Any questions? We are available.